Concerning black holes, would there be all gravitational wave vectors emanating into the poles of the black holes? I'm sorry, I don't know if that makes sense, but
okay, so
just these are viewer questions.
Sure. So a single black hole by itself doesn't emit gravitational waves. If it's just sitting there by itself, rotating around, it just sits there perfectly still. If two black holes are orbiting each other,
yes,
then gravitational waves get emitted out to far away to where the Earth might see them. Now, if the holes are far enough away that it still makes sense to describe it this way, you could imagine some tiny part of those gravitational waves falling down the other black hole's horizon. But really, when the holes get close enough together, it doesn't really... I mean, the space and time are curved, but you wouldn't really think of them as waves until you get farther away, usually.
I mean, maybe I'm not sure if this question is asking it, but like when you have the system, it's radiating gravitational waves in all directions away from itself. And they're stronger along the axis, so along the axis of rotation, they're the strongest going up and down, and they're weaker going out to the sides, but they're present in kind of a peanut shape for the amplitude. So that could be what you're asking.
Yeah, I don't know. I wasn't quite sure.
I should have been, I should have talked to them last night, but I didn't get a response. So, at what distance would planet Earth be safe from a GRB generated by a black hole or neutron star collision?
Depends on if we're in the way of the jet or not.
So, but what would be like a safe light year distance or parsec distance?
Well, jets can be many light years long, right?
Well, those are. Those are usually, I'm not sure exactly. It depends. There's the ones we've seen from the galactic merger type, the active galactic nucleus. They have jets that are going, thousands of light years.
Yeah, but those are in other galaxies.
Yeah, or millions of light years.
So, I mean, I think the point is any neutron stars or black holes that we know of that are close enough that we might be able to see them. They're far enough apart that away from us, it's not really a big threat.
Yeah, I don't remember the number right now. But I think we look at some of the candidate we know of no candidate system around us, like a supermassive star that might kind of collapse and maybe produce a type of GRB. But even if something happens in the neighborhood, there's the bright flashes we see are only from a small percentage of the directions. They're from these two axes, so it would have to be aimed right at us.
Oh, you're talking about the actual bore sight has to be like directed toward.
Yeah.
Okay.
So for it to be a more of a threat, but I don't remember the numbers in light years right now.
Okay, this is the last of the formal questions, and we'll take our final break after this. In a science fiction related question, can advanced Type 2 civilizations house a neutron star theoretically, and if they could, what would be the potential uses of it? I'm sorry, it's so simple.
Communications?
So if you built like a big space station around, I don't know about a neutron star, but certainly if you built one around a black hole, you could imagine using it as a power source.
Yeah.
You could drain the rotational energy by dropping in matter in the... One way to do it would be to drop matter in just the right trajectory so that you extract rotational energy. This is called
a magnetized neutron star is like a huge dynamo.
Sure.
Wow.
So I would think power.
It'd be hard to create one of these.
Right.
What energy scale was the Type 2 civilization?
Well, Type 1's what, like 16 to 18? 10x 16, 18? That's in the terawatt range, like watt range. Type 2 is 25 to 35, I believe. Depending on, of course, how big their soul is.
Yeah, you'd be if you're handling a neutron star, you need to be dealing with energies greater than a sun.
Okay.
So, or maybe if you find one and you harness it, that's something else.
But then you'd also need pretty good technology just to get out into space because everything is fairly far apart on the size scale of people.